So before we look at one final example of calculating the derivative from our formal definition, I want to just go over some notation for the derivative with you. We've already seen f prime of x, that symbol which means find the derivative of our function. If we plug in a specific x value, we find the slope at a particular x value. Another symbol that we're often going to use is dy dx. That fraction that we're not actually going to treat like a fraction necessarily, it's just sort of a symbol. What this means is the derivative of y, which we're going to call our dependent variable, with respect to x, which I'm going to call my independent variable. You plug in an x, you get a y. Y depends on x. X you're kind of picking for yourself. Dy dx, the derivative of y with respect to x. Way more with this later, but for right now, it's just a symbol that means the derivative. It's another way we can describe this sometimes. We call what I'm about to write operator notation, d dx of f of x. This thing over here is called an operator. Just like addition, subtraction, multiplication, division are operators. This is the derivative operator, and it's saying, let's find the derivative of that function over there. We'll see that notation used in section 2.2. One final example. If y equals 2 over x plus 3, I want to find dy dx. When I'm done, I want to find the equation of a line tangent at x equals 0. If y equals 2 over x plus 3, I want to find dy dx. Once I'm done with that, I want to find the equation of a line tangent at x equals 0. So I need to find dy dx, which is just a fancy symbol for the derivative, the slope of a tangent line. I didn't give you a formula for dy dx, but I gave you a formula for f prime of x, and it's not basically, it is the exact same thing. I'm going to say dy dx equals the limit as h approaches 0 of f of x plus h minus f of x over h. Just so I'm clear with my notation, I've got y equals 2 over x plus h, 2 over x plus 3. Could also say f of x equals 2 over x plus 3. It all means the same thing. I'm going to get the limits as h approaches 0 of, of 2 over x plus h plus 3 minus 2 over x plus 3 all over h. And I need to simplify this thing. Up top, you need to go subtract those fractions, which means you need to get a common denominator. What is your common denominator? Doesn't matter that they have an x and a 3 in common already. You need to have common factors, and there aren't any common factors. So your common denominator is x plus h plus 3 times x plus 3. We're going to get the limit as h approaches 0 of 2 over, let me just rewrite the problem, and then I'll make my common denominator thing happen. It's 2 over x plus 3 over h. So that first one, I'm going to multiply by x plus h over, no I'm not, sorry, x plus 3 over x plus 3. Second one, I'm going to multiply by x plus h plus 3 over x plus h plus 3. I'm going to do some distributing in the numerators, but I'm going to leave the denominator factored. So I'm going to get the limit as h approaches 0 of 2x plus 3 minus 2x minus 2h minus 6. Nope, I didn't get 2x plus 3, sorry. That should be 2x plus 6. It might be time for a nap. Over x plus 3, x plus h plus 3. And then this whole thing is over h. So after just some distributing in the numerators, you're going to get 2x plus 6 minus 2x minus 2h minus 6 over, leave your denominator factored, x plus 3 times x plus h plus 3, all over h. You know what? I'm not crazy about like a complex fraction with a fraction at the top but no fraction at the bottom. So just for fun, I'll change my denominator into a fraction as well and make it h over 1. This is going to give me the limit as h approaches 0 of the top is just negative 2h over x plus 3 times x plus h plus 3. That's all over h over 1. But you know what? Rather than dividing by h over 1, how about I multiply by the reciprocal? How about I multiply by 1 over h? I'm going to continue to clean this up. I'm going to get the limit as h approaches 0 of negative 2h over h times x plus 3, x plus h plus 3. I think I might be going a little fast, so please use pause if you need to. But I can cancel my h's now. This is the limit as h approaches 0 of negative 2 over x plus 3 times x plus h plus 3. I'm going to plug in 0 for h, and I'm going to get, let's see, negative 2 over x plus 3 times x plus 0 plus 3. And I think I can finish by saying dy dx, or f prime of x, whatever, it's all kind of the same thing, is negative 2 over x plus 3 in parentheses squared. I wanted you to see the derivative of a polynomial, of a radical function like the last example, and a rational function like this one. If you can handle those three types, you're set with this formal stuff. Now, I want the equation of a tangent line. Well, the equation of a tangent line, y, hold on, tangent line, y minus y1 equals m times x minus x1. And I told you I wanted to do this at x equals 0. So I know my x1. But I don't know my y1, I don't know my m. How can I find my y1? I'm just going to go and plug back into the original function. I'm going to go find f of 0, which is going to give me 2 over 0 plus 3, or 2/3. How am I going to find m? I'm going to go and plug into the derivative. I'm going to get f prime of 0 equals negative 2 over 0 plus 3 squared. That's negative 2/9, I think, I hope. My tangent line is going to be y minus 2/3 equals negative 2/9 times x minus 0, or just x. Either way is going to work. Let's check that with Desmos. So another one that I want to check in Desmos, my function was f of x, or y, equals 2 over x plus 3. I wanted to find the tangent line at x equals 0, and I calculated it to be y minus 2/3 equals negative 2/9 times x, or times x minus 0. Oh, isn't that nice? Again, perfectly tangent line to that function at x equals 0. Once again, everything worked.